Uh, Hi everyone, this is Shubham. Welcome to my Hashi Talk. Word of intro about me. I am a senior developer in ServiceNow Bangalore Development Center. My team handles ServiceNow IT operations management products, also known as ITOM. So I hail from the beautiful lake town of Nainital in Uttarakhand, which is in the northern part of India. So I have around 7.5 years of experience working in IT with different domains. And I have various hobbies like sports, bit of music, trying out different cuisines of food, and a little bit of travel, especially the Himalayas. So that's a bit about me. So coming to the agenda for this talk today. Uh, so this brings me to giving you more insights on what my team does. So as we all know, ServiceNow is the standard process workhorse for the industry. Our team innovates and develops products related to provisioning and governance of resources on cloud. We have various stories for IT, for the DevOps, and etc. I'll take you through some of these stories, which we have achieved with Terraform and the technical nitty-gritties of it as well. But other than provisioning, we own a few products in the areas of cloud governance as well. And we constantly look for more and more solutions in this domain. Some of the other products based on this are cloud configuration governance, tag-based governance. So coming to the agenda here, we will start with the introduction to our product, cloud provisioning and governance. So this is our standard product for provisioning resources on the cloud, or we can say exposing cloud resources as a catalog. So this is to build the foundation for the Terraform connector. So next we'll talk more about how we have overlaid Hashi products on top of ServiceNow. I'll be focusing on the Terraform part of it, that is the Terraform connector. We will discuss about how we have created magic for our customers by combining ServiceNow with the capabilities of Terraform. So after the introduction to Terraform connector, we will move on to interesting stories for IT and DevOps that we have achieved via the Terraform connector and this integration. One of the interesting stories is change governance, where we observed that we were able to reduce the production deployment time of our customers from 3.5 months to 3.5 hours. We'll discuss more about this story among others, and then next we'll move to the technical how part of it. We'll dig a little deeper on how it works, and then we will be concluding this talk with a quick demo. So we'll be using the standard ServiceNow Employee Center to find the catalog offering to request a multi-VM stack on AWS, which goes through Terraform. Now, after provisioning, we will see a more advanced view of the request and the stack in the Cloud Admin portal. We will also explore other capabilities like day two operations on the stack. So let's move on to the introduction to cloud provisioning and governance. Uh, so quick introduction to cloud provisioning and governance, which we fondly call CPG in short. So this slide gives a holistic picture of the features and capabilities. So in a world where cloud activities are driven through code, right? So like scripts, calling APIs and JSON, YAML templates and everything for deployments. So we provide an ability to run all the cloud activities on top of the secure ServiceNow platform. So we have out-of-the-box support for various IAC technologies, and this is where Terraform will come in. So we support cloud native technologies like CFT, ARM, and everything. And we support the multi-cloud technologies like Terraform. So this enables the complete lifecycle management for cloud resources. The principle here is that ServiceNow enables this non-intrusively. So any app developer can initiate this from a DevOps pipeline. But underlying ServiceNow governance capabilities will be run to ensure rules and policies for the deployment are met. So we also have day two operations like start, stop, terminate, or update a cloud resource. And there also we have multiple approaches like scripts, integration hub flows, which is like another low code, no code interactive platform capability, and our exhaustive API layer called Cloud API, or integrations to Ansible and all these things. So this is a single platform from where all the cloud operations can be run. So like day one provisioning flows, or day two operations, creation of cloud offerings, or the governance aspect like policies, tagging, you name it. Okay. So last slide was more about the product capabilities as a whole. Uh, uh, to set up the foundation, here's a more solution oriented picture. So in brief, this is our cloud provisioning story. Again, wanted to highlight on the same platform story here, single platform story, one platform for all the cloud operations, which manages end-to-end life cycle of the cloud operations. So I'll quickly move on to the next slide, in which we apply the Hashi solutions overlay on top of this. So this is where magic happens. When we introduce Hashi solutions here, I mentioned both Vault and Terraform. Some of our customers use HCP Vault for their credential management, but I'll only be covering Terraform connector in this talk. So when we introduce Terraform connector on top of ServiceNow, it enables us to ingest multi-cloud Terraform templates and expose them as catalog offerings, catalog items for our end users. And then again, use Terraform to deploy or update resources on the cloud via calls made from the ServiceNow, from our mid server. We support both Terraform Cloud or Enterprise offering as well as the Terraform open source server. So a simple story would be a simple IT request. Let's say an employee requiring a virtual machine for some of their internal work or testing or something. They can simply find the respective catalog item in their ServiceNow instance, and they can request, and the corresponding Terraform template will be called, and the request invokes a call to Terraform, and VMs are deployed on the cloud. The provisioned resources are also automatically updated on the CMDB. So CMDB is always up to date with the latest changes in the cloud as well. So I wanted to focus on the point that this is not just a solution for the IT. This is also a change governance solution for the DevOps. So consider this: whenever we are pushing out resources via Terraform in a declarative mode, we are making changes to the environment. So in enterprise, these changes can be significant, right? They can carry significant impact. We may not know what services are we impacting, or whether we need approval and all that stuff. What ServiceNow capabilities have to offer here is a governed approach on deploying and taking actions on the cloud. The typical approach that we follow is that the user goes to the catalog and searches for the appropriate catalog item. And when they find the matching items, they can make a request for a day one operation, like a deployment of a VM or a pass, or a day two action on the stack, like let's say adding a disk to the VM or turning on encryption on an S3 bucket. It all goes through pre-approved set of changes. So for dev or test infrastructures, this is a bit of an overkill. So an engineer could use a test account and all for testing changes. When it comes to production, that's where ServiceNow plus Terraform magic comes into picture. And like I said before, it has helped the production deployment times of our customers significantly. Simply because earlier approvals were stuck hanging on each desks and all that, but now it's end-to-end automated. The actual call to Terraform is also automated. So the question is, how do we achieve that? So how do we convert Terraform templates to catalog items? So this slide gives a brief idea on that front. So here we have taken the example of Terraform Cloud, but we do support Terraform open source as well. The concept remains similar. So first of all, there is an admin who will set up the Terraform as well as the VCS credentials on the ServiceNow instance. So in version control systems, we support discovery of templates from GitHub, GitLab, and Azure DevOps. We also support, other than the cloud versions, we also support enterprise self-hosted versions of them as well, in GitLab, GitHub Enterprise, and GitLab community and other things. So admin will first run a discovery on the Terraform cloud to list out the workspaces and stuff, and list of the configured VCS accounts from the Terraform side. So then he will associate the VCS credentials with the particular VCS account, which is discovered. And then the next level VCS discovery is made to discover the list of repos and branches from that VCS provider. So we call these repos IAC artifacts or config installables. So in case of Terraform open source, this thing is achieved with a single level discovery, where the admin will configure the SSH credentials of that Terraform open source server and discovers these artifacts from the specified root directory. So we'll read files from that directory and list everything again as a config installable. So then we come to the catalog designer. The designer will create the catalog item from that discovered template. The designer will make use of that template. So ServiceNow here will read the template, figure out the provider, modules, and other stuff, expose out the variables there, and makes those variables available as a part of that catalog item. So we can see here the list of all the jobs of the catalog designer, other integration scripts, tagging policies, day two actions, and everything. So keeping the catalog item updated with the latest changes from the VCS. So we also have a concept of scheduled IAC discovery, in which the discovery of templates from the VCS is done in a scheduled manner automatically. If changes are detected, then change tasks are automatically created and catalog owner is assigned those change tasks and we can take the action to keep the catalog item updated. So now coming to the governance user. So governance user will set up the policies for all the provisioning and day two operations, as well as the other tasks defined here. So now coming to the end user, who is the requester. So this is the part where the end user will come and request the stack via the offering in the catalog. It's a pretty end-to-end process. The provisioning magic here is that the request handling is done in such a way that we are actually working very closely integrated way on top of CMDB. So the request is sent to Terraform, provisioning is done, and as soon as the provisioning is done, the objects are automatically updated on the CMDB. So we have ways to make targeted discoveries from the cloud on those provisioned resources. So that way our SRE operations or observability and everything, that is also updated with the real-time information of our cloud with the help of real-time CMDB. Okay, so after that, ops team can take over and work on top of these resources. They can take a Terraform route or another route. So this is how the flow, a typical flow happens. Okay, so here is another view of a step-by-step thing. So on the Terraform end, currently we are not reached the ServiceNow end. This is the configuration of the Terraform end. The Terraform admin will configure the Terraform enterprise account or cloud account, and it will associate the VCS systems like, let's say, GitHub or something. And then the Terraform designer, the person who is designing the templates, right? So the Terraform designer will create the templates as a GitHub repos. And they'll take care of the modules, resources, variables, and everything. Now we come to the ServiceNow side. So on the ServiceNow side, the cloud admin will, like we discussed in the last slide, the cloud admin will discover the TF using the TFE provider. Cloud admin will discover the VCS systems, and then the second level discovery of that particular VCS system to get a list of repos, the config installables, and the catalog item designer. So the discussed again, catalog item designer will again create the catalog items, generating the variables and everything, and the catalog item will be created. So again, I would like to mention here that this is more a strategy for production changes, and typically not for development. Here is a typical example of a branching strategy. The branch naming here is something inspired from how we do app development at ServiceNow internally. So the naming conventions could be different, but the concept remains same. So in all the development can be done on the dev branches and everything, but validation and everything in UAT and staging branches. And then once tested and approved, it is moved to production branches, and then it is submitted to ServiceNow. So this is where ServiceNow takes over the governed workflow including Terraform. So the state file and everything is also maintained. We do not come in the way of any state file or anything. We leave the state file, we update the CMDB, ensuring that we discover the infrastructure that is provisioned, and we discover it and keep it in the CMDB. So here is another slide to understand that. So we are assuming code changes via ID and some build pipeline like Jenkins and all that is done outside of ServiceNow. And then finally, the release deployment, that is where this comes into picture. This is the place that ServiceNow helps. And by bringing this part to ServiceNow, we take all the advantages of the capabilities that we have discussed. Just by creating this infrastructure as a ServiceNow catalog item, we take all these benefits that are listed. The security, the compliance, governance, all the approval rules will be applied, the permissions can be set up, everything will be audited. We'll take care of change management on its own. So everything will be taken care of. So let's see all of this in action with a quick demo. So we will use ServiceNow with Terraform connector to discover from a Terraform cloud account. And then we'll discover templates from a GitHub account. And we'll create a catalog item using a template. And then using the catalog, let's provision IT. So in the demo, first we will take a ServiceNow instance and we will connect the Terraform cloud account with the help of a Terraform config provider. So we will go to the cloud admin portal. This is where the cloud admin and catalog designer primarily work. And I'll go to design, I'll go to manage, and I'll go to config management. This is the place where we create different cloud config providers. So we will open up create config provider. So I'll choose SPTFE demo, the name of it. And in the provider, I will choose Terraform Enterprise, which represents both enterprise and cloud. So I'll enter the organization here. In the URL, I'll put the API URL from which we can access the Terraform APIs. Okay, this is the base URL for the Terraform APIs, as we all know. In the server type, I'll choose cloud. This is a cloud account. In the credential, I have entered the credential for the API key of that account. So I'll link it to that. In the versions, these are the versions that we support in Terraform connector. The latest version that we support right now is 1.2.0. Any new version support can be very easily added, by the way, but I'll go with 1.2.0 for now, and I'll submit this. As soon as I submit this, I will go to this inside this provider, and I can see the Discover Now button. This button will, on clicking this button, it will trigger a discovery on that Terraform cloud account, and it will bring out a list of all workspaces, the configured version control systems, agent pools, and everything. So we'll wait for this one. Okay, we can see that it has brought a list of all the workspaces and everything. It has done the discovery from the Terraform cloud account. So we are more concerned with the VCS systems right now. This is a list of all the VCSs that are configured in that Terraform account. I'll choose one of the GitHub accounts that I use. So this is a GitHub account that is configured at the Terraform side. And we can see that this is that GitHub account. And I will enter the configured GitHub key here. This is the credential for the GitHub key that I've entered. And as soon as I save it, I will see that I have a Find Branches and Repositories button. Once I click this button, it will try to bring all the branches and repositories from this GitHub repo. Let's wait for this. Okay. Okay, so we can see that all the Terraform templates, all the repositories in this GitHub account with all the branches, they are discovered here. And now we will create a catalog item with the help of one of these repositories. So for that, we'll go to Design and Cloud Catalog Items. This is the place in the portal where the catalog designer mainly creates and designs the catalog item. I'll create a new catalog item. In the new catalog item, I'll just name it SPTFE demo catalog. Okay, and in the source, we will choose configuration management template, because the others are for for the cloud templates like CFT, GDM, and other things. In the provider, I will choose that the provider that we just created. So let me just open this related list. Okay, I'll choose SPTFE demo. This is the provider that we created. I'll quickly save this. Okay, so this is now saved. And now we have to fill this catalog item with a cloud template. In the related lists of cloud templates, I'll go to new, and I will see that I have to give a config installable. So all those repos that we discovered, repos and branches, they are the config installables for this provider. As soon as I open this, I'll see a list of those repos. I am going to choose one catalog that I know. So this, the master branch of this template is what I'm going to choose. So as soon as I click save, we will see that it will bring everything from that repo, and it will compile all the templates in that repo into one overall template. And it has created all the variables from these templates. Okay, now we will activate this catalog. We'll wait for a bit. It parses everything in this template, the variables and everything. It does all its processing, and let's wait for it to get activated. And then we'll see it will be available for us to be used in that catalog. Okay, so this state of this catalog is active now, and we are back to the catalog item screen. We can see that this catalog item has now got variable sets and everything. So this is the place where catalog designer is supposed to add more to this catalog, some post-provision operations or pre-provision operations, rules, lifecycle operations, which are the day two operations. Everything the catalog designer can do. This catalog is activated now. In the variable sets, we will see that apart from general info, we'll see if we go to the provision part, we will see that all the variables in that template are now exposed as cloud variables in this catalog item. So now we are ready to activate this catalog item as a whole and publish it. As soon as we do that, it will be available for any user, end user, to be used as a catalog offering. Okay, let's go to the cloud user portal and find this catalog item and see how it appears on the catalog form when the end user will request it. Okay, so we go to launch a stack, and this will show us a list of all catalog items that are available. So this is a list of all the catalog items, and this is our catalog item. We click on launch and it will open the catalog form. So this is the general info section common to all the Terraform catalogs, like do you want to use existing workspace or the cloud account and everything, all the details, right? So if we go to that provision tag, this is where all the other form related details are there. These are all filled with the default values. The requesting user can of course change all of these values as per the need. So in the last part of this demo, we will provision one of these catalogs from the end user and how the request form and everything looks like. So we will initiate our request with the employee center. This is a standard ServiceNow homepage which any employee can access. So if someone wants a laptop, they will go to this portal. Someone wants an AWS VM, they'll go to this portal. So this is a unified kind of that form. So one of the catalog items that we have created, we have made it a part of this service catalog. This is an AWS TFO multi-VM catalog. As the name suggests, this goes through Terraform open source box that we have. And this is an AWS VM catalog where we can request a certain number of VMs as a part of our stack. So we will open this catalog item. Right, so this will load a list of cloud accounts. We can choose the location here. We'll see all of these items. We'll select the user group, a user group that is created. Let's select 3 in the number of VMs that we would like. In the size, let's go with t2.nano for the purpose of demo. Right, and this use existing workspace, right? I'll choose no because I want to create a new workspace. Use existing workspace is marked as yes for the change governance use cases if we want to update an existing infrastructure in the change of the templates or stuff like that. We've discussed about it in the past slides. We have this lease end date and then scheduling profile like 8 to 5 or such kind of things. We can configure our stack to be running only at these scheduling profiles. So these options are there. We will click on order now to initiate this request. So once we click order now, we have got a request number here. To see this request in detail, we'll have to go to the user portal, the same portal that we discussed before. So I'll refresh it and I will see that in the activities section, it has created this request that we had. The request goes through approval and everything. We can have certain approval policies in place as well. This is by default approved in our case, and it will show us the details of what is currently going on with this stack. So we can see that all the approvals here are done and the capacity checks and everything. And right now it is deploying the stack, which means it is currently talking with Terraform and Terraform open source server and asking the Terraform server to run the Terraform provisioning commands so that the stack can be provisioned. So as a result of the commands that were executed, we have successfully provisioned the 3 VMs that we requested. We can see the resource IDs as well. And currently it is invoking the targeted discovery for these resources so that everything can be automatically, instantaneously updated on the CMDB as well. So we can see that our stack is successfully provisioned. All the resources are there. To see the details of the stack, we will click on view stack details. This is how our stack looks like. These are the storage volumes. These are the machines, my machine 0, 1, 2, the NICs, and this is the whole stack. We can also see that everything is already in CMDB now. If we click on view dependency, it will load the dependency map of our complete stack, where we can see our machines and everything. So that is one part, that everything is immediately moved to CMDB as well. And we can see that other than the provision, we have these day 2 operations as well on these, deprovisioning of the stack and other things like lease modification and everything. Other than this complete stack level operations, we can go to a particular machine or particular resource in this stack, and we can select the resource level operation as well. Like we can stop one particular machine from this stack, and we can similarly perform these day 2 operations on particular resources. Okay, so this is how the cloud provisioning use cases work from ServiceNow. We have successfully provisioned a 3 VM stack using Terraform open source with the help of ServiceNow. And we have also discovered all of them immediately and kept them all in CMDB as well. So this is the end of the demo. So thank you everyone for listening to my Hashi talk. And for any more information, my email is mentioned here. Thank you all for listening. Have a great day. Bye-bye.